Welcome, everyone. Let's put our headphones on. I hope you guys are having a great time at reInvent 2025. I'm thrilled here to talk to you about our exciting new release, routing policy with AWS Cloud WAN. I'm joined here today by my co-speakers, Chijun, Senior Network Engineer from Airbnb, and Sridhar, Principal Product Manager, AWS Cloud WAN. Now, building hybrid connectivity, in fact, network connectivity in general is tough. It's complex, especially when you have multiple on-premises networks, which needs to connect to VPCs, not just in one region, but in multiple regions. And then you have ever-changing application connectivity requirements through which you need to start tweaking things. That's where AWS Cloud WAN comes in. It acts as the brain of your network, providing robust connectivity to all your networks. Now, if you look under the covers, we have core network edges in every region. These are highly available, scalable routing entities, which is where all the magic happens. They let you establish connectivity to your on-premise data centers via AWS Direct Connect, or site-to-site VPN, or SD-WAN connectivity using connect attachments. And it also connects to your existing transit gateways. It enables traffic flow not just on-prem to AWS, but also AWS to AWS, intra-region, as well as inter-region. All these traffic flows can be inspected with a single click using AWS Cloud WAN service insertion feature. Now, the great thing about Cloud WAN is everything is dynamic routing. So you don't have to write any static routes. Routes are getting exchanged dynamically. Now, while that's a great thing to have, we know when you have hundreds of VPCs, multiple on-premises networks, route exchange can become complex, and that's where the new routing policy is really powerful. So in today's session, we are going to do a very quick recap of AWS Cloud WAN. This will be a rapid fire. This is a 400-level session, so we want to spend most of our time talking about routing policies. Then we'll hear from Airbnb on how they are using AWS Cloud WAN. And then we'll dive into routing policy, along with multiple use cases and a bunch of demos. So let's do a rapid fire of what AWS Cloud WAN is. In AWS Cloud WAN, everything is through a policy. So here we define a policy. We give it 3 locations. When you execute this policy, behind the scenes, 3 CNEs, 1 in each region, is automatically provisioned and fully meshed. Then you define segments. Segments are fully isolated routing boundaries. Here we define 3 segments: production, development, hybrid. Now, we take our remote networks, including VPCs, transit gateways, whatnot, and attach it to our Cloud WAN. But then we need to associate to the right segment. For that, we need an attachment policy. Here we're using tags to automatically associate the right attachment to the right segment. And then finally, we need to share routes between segments, because segments are fully isolated by default. So to enable sharing, we have this share segment action. The next feature of Cloud WAN is service insertion, which lets you insert network appliances into your traffic path. There are 2 traffic paths we'll talk about. The first one is inter-segment traffic path. Here, we write a policy saying prod segment, when traffic is being sent to development, send via network function group. And here we're using the dual hop mode, which means the traffic is getting inspected at every inspection region in both the VPCs. Now the traffic, both the request and the response, is getting inspected. The next traffic path we have is the single hop mode. So prod segment, when sent to development, sent by network function group. But as you can see on the bottom, with edge overrides, as traffic is flowing between US East 1 and US West 2, use US East 1. So it deterministically always sends traffic for inspection to the inspection VPC in US East 1. The next we have is for internet egress traffic. Here the policy says any traffic exiting segment development, send to network function group. Right? And we also have an edge overrides here, which says if my region does not have an inspection VPC, in this case US East 2, always use US East 1. So this edge overrides functionality gives you that deterministic way in how you set this up. Now, I went really fast. I told you it was a rapid fire. So if you want to learn more on how all of that works, we went into a much more depth last year's reInvent session. So you can definitely check that out. So now I want to hand it over to Chijun to come and talk about how Airbnb is using Cloud WAN.
Thank you. Hi, everyone. Good afternoon. And I'm happy to be here to share our experience with AWS Cloud WAN. And I would like to start with a very quick story. It's like over 6 years ago when I first joined Airbnb, and there was an engineer from another team once asked me why configuring network cannot be as easy as software development. Back then, I don't know how to answer. It's like configuring a network, it involves so many different types of devices, and there is no simple and unified way to automate all the configurations. So also the version control for the network change is also very difficult. And but this question stuck in my head for quite a long time. And until like 3 years ago, and then when I learned about the AWS Cloud WAN, I think I may find an answer. So I would like to share with our experience. And for those who you don't know me, and my name is Chi Jun. I'm the lead engineer for the Cloud WAN migration project in Airbnb. So Airbnb is we started from a very simple idea, is to like help everyone to find a place to stay, to connect the travelers with all the hosts all around the world. And over the past years, this simple idea has grown and into a global platform. And today, now we are hosting over 2 billion guests. And also Airbnb is a company with 7,300 employees. And my team, the network engineering team, so we will deploy and build a global network to support all the connectivities all around the world. Our goal is to provide a secure and also reliable networks. And let's dive into the network parts. So you may see a graph here. It looks very familiar for all the network engineers. So in 2013, that's the time Airbnb grew so fast, and we have a very fast increased demand for the audio and video traffic. So we need to design a network and to support the low latency and high reliability. And that's why we built a physical data center network during that time. And in the middle part, there is a physical data center, and that's our backbones. It interconnects all the network components within our networks, like all the services deployed in the AWS Cloud WAN, AWS VPCs, and also our client VPNs, and all the offices, and many other external networks. This model works great, and it provides us a secure and then a reliable network connectivities. And let's fast forward to the 2021. It's the time for our physical data center to approach the end of life. So it's a great time for our team to step back a little bit and rethink how we can design the network. Like what is the next generation network looks like? And more importantly, how can we build a network to support the fast-growing cloud-based services? So we built an initial proof of concept design, like in this simple graph. It shows the simple connection about our proof of concept design. So we use the full mesh connection for the AWS transit gateways. This design works great. The test works great. But at the same time, we figure out AWS Cloud WAN is mature very fast as a product. So we do a evaluation on it and figure out AWS Cloud WAN is actually an even better fit for our needs. So the Cloud WAN, they support the dynamic routings and have a strong automation support. And also one important thing, it has a simpler infrastructure. So here is the graph shows like how we use Cloud WAN in our network currently. And in this graph, like Cloud WAN is the middle part, also our backbone. Because Cloud WAN is a global platform, and it supports the dynamic routings. So we no longer need to use the full mesh connectivities, just like the transit gateway solutions. And this solution works great. And also because the Cloud WAN in the middle as our main backbone, and we can use the core network policy to centrally manage all the network components in our network. And also you may see the inspection VPC in the bottom part. So that is for our layer 7 firewalls. The security is an important component in our network. So our standard approach is to build a layer 7 firewalls to inspect and control all the traffic on our network. And this design works very great with the Cloud WAN. And also I want to mention about is the Terraform enterprise support. That is the support enable us to deploy and manage our network all through code. So with the built-in version control and easy rollback for the network change. So that answers the question from 6 years ago. And well, the migration to Cloud WAN is very successful. And we have already put our production network in Cloud WAN for over 1 year, almost 2 years. And this is the benefits we see. The first one I would like to mention is the cost savings. So now, because we decommission all the physical data centers and also the circuits connects them, and we are able to save multi-million dollars every year. And another one is the automation part. That's something we really like it. And with the automation, we are able to use the code and then to deploy, manage our whole network. And it's easier for our network change because they have the built-in version control and just have an easy rollback. And that helps us a lot. And also another one is the rapid deployment. Because everything is based on code, we can use a modularized coding and then to spin up a new data center in a new region within 2 days. Compared in the old days before the migration, like for the physical data centers, it could take like weeks to months and involve multiple teams' effort to build a physical data center. And now we can do it within 2 days. And one thing I also would like to mention is the operational efficiency. After we migrate our network to the AWS Cloud WAN, we are seeing improved uptime. And also, AWS Cloud WAN, they provide a centralized place for us to do the monitoring. And that helps us a lot. As a network engineer, I used to get paid a lot for the network issue, like the network device hardware issue, cabling issues, SFPs, and all the stuff, or circuits issue. And after the migration, AWS has helped us to handle all the underlying circuits connectivities. So that frees up our efforts and allow our team to focus more strategic and more impactful tasks instead of the routine maintenance. Yeah, and with all these changes, and it basically transformed our way to deploy and manage our network. And we are really happy, and then with the less routine maintenance effort, but we still ensure a high reliability networks. And well, currently we are still working with AWS to improve further with our current network. Here is the challenge we're still facing. So one of them is the static routes. We still need to configure some static routes. Mostly is for our firewall inspection because our environment's requirements. And also, our firewall currently, they have to do a double inspection design, and which we would like to move away. And another thing is like we have a lot of requests from our trusted team. They would like to self-manage the routing to Cloud WAN right now. And also, we would like to have an easier route filtering. But the good news is AWS is actively working on it. And now the service insertion features and also the advanced policy routing, and that could potentially fix these challenges. And we are very excited to testing and applying these new features, and hopefully we will improve the network even further. So to conclude, and then our migration to the Cloud WAN is very successful, and we have enjoyed a lot of benefits, as I mentioned. And we are still working on the challenge here, and I will hand over to Sridhar, and then he will talk more about the advanced routing policies. I hope this talk will inspire you and to look into this technology and maybe try it out. Thank you for your time.
Thanks, Pete. Hello, everyone. Just a quick intro. So my name is Sridhar Kulkarni. I lead product management here at AWS for a couple connectivity services, Cloud WAN, Transit Gateway, and Direct Connect. So great to see you all here. And I just want to take an opportunity to thank Fusion and the Airbnb team for putting trust in the Cloud WAN service. I know you were early adopters of the service from multiple years back. And it's amazing to see you grow your network with Cloud WAN as the backbone for that. So thanks for that. And also sincerely appreciate all the feedback that your team has provided over the years. It helps us make our products better. And by the way, that applies to a lot of the folks in this audience, because I have so many familiar faces here. Really, your feedback makes us come up with better services and better products. So speaking of making the service better, today I'm excited to talk about a brand new capability that we just launched a couple of weeks ago. It's called Routing Policy on Cloud WAN, and it gives you advanced routing capabilities in order to essentially control propagations within your network, right? It helps you manage your routing much better, and essentially it helps you customize your network as per your individual needs, okay? So before I get into the feature itself, I want to set the stage a little bit, give you some context in terms of like why this feature is so important and why this capability is so value-driven, right? So let's look at a typical Cloud WAN network. Let's say 3 regions. Obviously, there's a CNE per region, and then you have 3 environments: prod, dev, and hybrid. Your prod and dev VPCs are attached to your prod and dev segments, and then your hybrid segment is attached to, it's connected to, let's say, like your external networks, right? Like your data center that's connected via DX attachment to the hybrid segment, or you could have remote offices that have site-to-site VPNs that are coming into the hybrid segment, or alternatively, you could have SD-WAN-based networks, right? So you could use something like a tunnel-less connect attachment that's coming from an SD-WAN appliance, and then attach that to the hybrid segment, right? And all of these attachments that I'm talking about right now are BGP-capable attachments, right? So there's propagations, route advertisements, and learnings in both directions dynamically on all these attachments. And then similarly, transit gateway peering attachment, right? Let's say you have a different group, or you do an acquisition, and they're using transit gateways to attach their VPCs. Then you can take the peering connection from the transit gateway and attach it to the prod or the dev segment using route table attachments, so that you can maintain the segmentation end to end. So the point being, and all these routes are, by the way, propagated not just on these attachments, but also across regions, right? Like Cloud WAN supports like dynamic routing as a table stakes feature, right? It automatically propagates all the routes across regions, and then same thing across segments. Like you can share routes across segments, and routes get propagated. So this is amazing. It's a fully dynamic network, and customers love it. But then there's some challenges, right? That this kind of an environment can present to you. And so the number one challenge is uncontrolled route propagations, right? So we have heard from you and from customers over the years that they want to be able to control route propagations at all these distribution points, right? Or the attachments across segments, or across regions, and that could be just to minimize the blast radius of propagations or whatnot, but they need some control in terms of what routes get propagated globally versus locally, right? The second thing is indeterministic traffic patterns, right? So again, a fully dynamic network, multi-pathing is super common. From a remote site, you could have multiple paths coming into the core network, one via SD-WAN, the other one via Direct Connect. And then in such a scenario, you want the control to sort of do some sort of path preferences, right? You want to say, for these prefixes, I really want that traffic to come over SD-WAN, right? Versus this other prefixes, I prefer my Direct Connect path. So that level of control, so that you can have some deterministic traffic patterns through this dynamic network, that's super important, right? And then route scaling, again, this is sort of like a derivative effect of the uncontrolled route propagations issue, is like, let's say if you're connected to a partner network, and then you advertise all the routes in your segment to that partner network, there's a chance that you're going to overwhelm the routing limits, right, on that router on the other side, or vice versa, right? So you want to be able to sort of control those propagations to prevent any scaling related issues. And then last but not the least, troubleshooting. It's a super dynamic environment, and then you need that advanced visibility into your routing databases to figure out like where you're learning these routes from, and then what are the advanced attributes that are associated with these routes. Right? So these are some of the challenges, and these are the ones that we have addressed in this brand new routing policy capability we just launched a couple of weeks back. It gives you fine-grained routing controls at each of those distribution points that I talked about in the previous slide, right? On the attachments, across regions, across segments. Optimize traffic patterns. It gives you the ability to modify the advanced BGP attributes, like local pref or ASPath prepends or whatnot, on Cloud WAN itself, so that you can influence paths coming in or influence traffic coming in over these different paths. So optimizing traffic patterns, preventing asymmetric routing, right? All of that you can control using this feature. And then last but not the least, visibility, right? Again, you get full visibility into the routing database, into the RIB, as you say, the routing information base, so that you can proactively troubleshoot issues or ensure that the way the network is behaving or the way the traffic is flowing is as per the way you want it, it's as per your policy. Right? So let's look at the features in a little bit more detail. So the first feature that we are offering as part of this capability is route filtering. So you will be able to allow or drop routes or prefixes both in inbound and outbound direction for all these different attachment types. The VPN, DX, transit gateway, route table attachments, or connect attachments. Right? Allow or drop prefixes. You can also do the same thing on VPC attachments. Although VPC attachment is not classical BGP, but it does automatically propagate routes from VPC into the segment route table, right? So you can control that by adding filters, inbound only filters on that attachment. You can also control route propagations across segments or filter routes, essentially, or allow or drop routes across segments, and then same thing between CNE to CNE. You can put filters on that distribution point. And then and I'll go into a little bit more detail in subsequent slides, but this is based on the classical match action philosophy. So you can match what prefixes you want to drop or the actions that you want to take based on certain attributes. So you can match here based on prefixes or standard BGP attributes like ASN numbers or BGP communities or MED values and so on and so forth. Right? The second important feature is route summarization. Right? Again, this goes back to preventing scaling issues by advertising all the routes on certain attachments. Right? So you will be able to advertise a summary route instead of multiple prefixes. Right? And then you can do that outbound across all these BGP capable attachments like VPN, DX, or connect attachments. And then here again, you can match based on prefixes. Right? And then thirdly, the BGP property modification. So this is where you can manipulate attributes like local preferences, MED value, BGP communities, or ASPath, right? You can do that again in both directions, inbound and outbound on all the BGP capable attachments across segments and regions. And then here you can match based on prefixes or standard BGP attributes, right? So this is sort of like in a nutshell, what are some of the, the detailed features that we're supporting with this capability. So let's look at how do you get started with this feature, or what does the policy definition look like, right? So there are two two major steps. One is the definition, the defining the routing policy, and then The second step is taking that routing policy and associating it into one of these distribution points, right? So let's look at step one, where you actually define the routing policy. Now, as I said, it's based on the classic match and action sort of a philosophy. So the first thing you do is you define match conditions. You define your match thing, and you have several match conditions that you can use. Like you can match based on a v4 or a v6 prefix. You can match based on a prefix that is part of a CIDR range, or match with a prefix list. A lot of our customers use prefix lists for ease of use rather than having to manage individual prefixes. It's so much more easier to use a prefix list, which is like a named reference, right? So you can match based on that, your customer-defined prefix list. You can match based on ASNs in the ASN path, or BGP communities, or MED values, right? So there is a lot of flexibility that this capability offers in terms of like what you can match against. Now, once you do your match condition, the second thing is defining the action, right? So for action, we support the classical filtering actions, such as you can drop the match prefix, or you can allow certain match prefix in the route updates that are coming in or going out. You can do summary routes in the outbound direction, so that's one of the action. You can add or remove ASNs to the ASN path, right? So you can prepend ASN list, remove ASN list, replace ASN list. You have actions like that. You can add or remove communities, set MED values, or set local preferences. So these are the actions that you can use corresponding to the match actions. Now let's take an example. Let's say your match condition is prefix equals, which is basically you're matching on an IPv4 or v6 prefix, and your action is you want to drop that route, or you want to drop that prefix in the, let's say, outbound route advertisement, right? So here's how the policy would look like for that operation. So your policy is essentially, you give it like a unique policy number. You give a policy name, a unique name, like here we are calling it outbound route filter. You give a description, and then you give the policy direction. Now this is important. There is a notion of directionality for routing policies, right? They are either in outbound direction or in inbound direction. So let's take an example. When I say outbound, from the perspective of an attachment, like let's say if you have a VPN attachment to a remote site, outbound is the route propagations that go from the CNE, segment route table, to your remote site, right? So that's the outbound direction. Inbound is anything that the remote site advertises and to the CNE, segment route table. So this policy, what you're saying is, its direction is outbound, which means you're going to control those routes that are advertised from the CNE to that remote site, right? So you specify the direction, and then you specify the rule. So every routing policy is essentially a collection of match action rules. So here you've defined a rule, you give a unique rule number, and then you give the match condition saying, hey, my prefix equals 192.168/16, and then you're saying the action is drop, right? So anything that matches 192.168/16 in the outbound direction, drop that. So that's the filter you defined using this policy. Now, the next step is to associate the policy that you just defined to a distribution point, right? So let's look at distribution points one at a time. So into segment, when you share routes across segments, what you can do is you can reference that routing policy that you just defined in the previous slide into this segment actions stanza, where you're sharing the two segments with each other, right? So here's an example of segment prod that got shared with segment dev, and then you are referencing the routing policy here. So any outbound propagations, meaning from prod to dev, it's going to filter out the 192.168/16 prefix that you defined in the routing policy, right? So this is giving you that granular control of what routes you want to propagate between across segments and which ones you want to filter out, right? So the next distribution point is between regions. Now here we have a new segment action called associate routing policy, and you specify the segment, the source region, destination region, and then again you reference the routing policy, right? So here's an example of how you do that. The new action, associate routing policy, edge location is US East 1, your peer edge location is US West 2, and then you have an outbound route filter that you're attaching or associating to those route propagations, right? So this is how you can do cross-region route propagation control. Again, you can do it in both outbound and inbound directions. The example here is for outbound, right? And then the last distribution point is on an attachment. So this is the most interesting one. So this is where we have come up with a new construct called a routing policy label. So at a high level, what you do is you take a routing policy, you map it to a label. So your label is just like a tag, right? Just like an AWS tag, a label is that identifier. It's sort of an indirection for that routing policy. And then what you do is you associate that label with the attachment, like when you're creating the attachments, right? So the routing policy, that's how it gets applied to the Cloud WAN attachments. So let's look at an example for how do you do the route policy association to attachments. So at the bottom there's an example of creating that label. This is done as part of the attachment routing policy rules, right? So just like you have attachment policy today, that's an existing construct which maps an attachment to a segment. This is a new construct which is called attachment routing policy rules, which matches to the routing policy to a label, right? So here you're mapping your outbound route filter policy that you defined in step 1 to the label called attachment route filter, and then you can call the API, the association API at the top, to associate that label with the attachment, right? So this is how you take a routing policy, map it to a label, and then map that to an attachment, and then that's how filters are set on individual attachments. Okay. All right. So the relationship between routing policy and label is many to one. So you can have multiple routing policies that you can map to a single label, and then the relationship between the label and the attachments is one to many. So you can take the same label, you can do the same outbound route filter as an example, where you are attaching, you can associate that with multiple attachments, right? And then this is the last slide for this section. So this is speaking to the observability piece. So now you have full visibility into the RIB. You can say for a segment or for an edge location, give me all the routing information, and it's going to dump the entire routing information base with all the advanced BGP attributes, so that you can use that for troubleshooting or for management, right? So with that, I'm going to hand it over to Sid to go into the advanced use cases.
Perfect. Thanks, Sridhar. So now we all understand how routing policy works. Let's look at some use cases and demo. Now, this is a demo environment in which I'll be illustrating and configuring routing policies. So I have 3 regions, 3 segments, standard setup. My prod VPCs are in the 10 range, dev VPCs are in the 172 range. And then to simulate my on-prem setup, I have SD-WAN connectivity using tunnelless connect, and that's advertising 164 routes. All right, so the first scenario we'll look at is route summarization. So what we want to do here is the routes which are being learned from the VPC at a CNE, that will get summarized as we send it on-prem. So my 10.0, 10.1, 10.2 prod VPCs routes will get summarized as 10.0/14. To implement this, step 1, we'll create a routing policy to match the VPC CIDR and summarize them. And then step 2, we'll apply the routing policy to the relevant attachments. So let's see how this works. So I have a routing policy, summarize prod VPCs. I give it a direction, outbound. I'm going to match on a prefix list, right? As Sridhar mentioned, it's much easier to manage VPC CIDRs using prefix lists. So I have a prefix list, prod VPCs, which I match on. And then the action is summarize. And I'm summarizing that to 10.0/14. Now let's apply that. So using the attachment route policy rules, I have a condition where I am associating the route policy to a label. And then we will associate the label to the attachment, right? Sridhar just talked about how we do this. So we do all of that. Okay, so let's see this in action. So I am going to, there you go. Yep, there you go. So we go into our console, and you can see I have my setup with 3 AWS regions. I go into my topology tree to just verify my setup. As you can see, I have dev and prod VPCs in US East 1, dev and prod VPCs in EU West 1, and then I have my hybrid attachment. This is my connect attachment with my connect peers. And I can see BGP is up, everything's running fine. Awesome. So I go back into my core network. I choose my latest policy. I'll edit the JSON. Now you can see my policy is pretty standard, just defining the edge location, segments. There's no routing policies in there. And I'll go ahead and add the routing policies. So let's jump back into a presentation, and I'll exactly copy the same syntax into my policy. Let's go back and take the attachment route policy rules and add that in as well. Now I am butchering the JSON formatting here, but it's okay, it works. That's all that matters. So let's go ahead, and that now is pending generation. So you can go into my prefix list associations, and you can see I've already associated prod VPC's prefix list with AWS Cloud WAN. So that's a step which you need to do. If I look at my prefix list, you can see I already have 10.0, 10.1, 10.2 CIDRs in my prefix list, so everything looks good. I go into my attachment, and this is my connect attachment. And here you can see routing policy label new. So I click that, and you can see I've already associated the connect label with my attachment. So that step already done. So now if we go back, this is my SD-WAN appliance, and I can check what routes I'm receiving. So you can see I'm receiving 10.0, 10.1, 10.2. So the summarization has not happened yet. So for summarization to work, and I can also see the exact ASN and the path. So this is all like the CNE ASNs. So we go back into the policy, and we go ahead and execute it. View apply change set. I'm sure you guys have done this 100 times. And we wait for the policy to get executed. And that should happen. There you go. And now we'll run the show IPBGP summary. And you can see now I have the summary route, 10.0/14. And the previous routes, 10.1, 10.2, 10.0 are gone. Right? So this our summarization is working. And you can see the route path is just my CNE, which I'm directly attached to. So just to summarize what happened here. Oops. Individual prefixes were suppressed. Only the summary route was advertised. And the non-specified prefixes, that was my 172 routes, still continue to advertise as normal. So the summary route is created upon the first match. It's advertised dynamically, so it's coming to BGP. And it is retracted once all the matching prefixes are removed. The summary route is treated as a new route, right? So it's originated by the CNE, and we saw in the demo that 10.0/14, the next hop was the CNE. So any other ASNs or any other BGP metrics behind that CNE is all removed. It's not carried forward. Now let's talk about route summarization policy strategy. So what we did here was global summarization. So all the prod VPCs across the regions, I created one summary route and advertised it down to my SD-WAN appliance. I don't recommend this for direct connect attachments because that's a global attachment, and it can lead to non-optimal routing. Let's see how. So let's say I have the same setup, and I'm advertising 10.0/8 down to my direct connect gateway. And my on-premises server wants to talk to, let's say, 10.1/16. So the traffic goes to direct connect gateway. Now, direct connect gateway sees 2 equal routes, one from CNE1, one from CNE2, both advertising 10/8. All the BGP attributes are the same. What route will transit gateway take? Direct connect gateway take? I don't know. It might just go to CNE2, and then CNE2 senses to CNE1. So that's not an optimal routing, right? So don't do this. So what you can do, and the same thing applies if you're using IPsec VPN, and your on-prem router sees 2 equal routes from the IPsec tunnels to the 2 different CNEs. So what you would rather do is per region summarization. So you have different summary routes per region. So you can see here it's 10.0/17 and 10.128/17, so 2 different routes. And you can also go a step ahead and do per region, per segment summarization. So you can see here I have different routes for prod, for development in region 1 and region 2. Or you can do everything, right? So for direct connect, you can do per region, per segment summarization. And for attachments like tunnel-less connect, where it would make sense, you can have the global summarization, right? So you can control, mix and match. Okay, so our next scenario is to restrict overlapping VPC CIDR. So let's say you have your SD-WAN set up, you're connecting to remote offices, you make a new office acquisition, and it has 172.16 range. Oh no, that overlaps with our VPC in US West 2. What do we do? One of the great things about VPCs is that you can add a secondary CIDR. So we add a non-overlapping secondary CIDR. And now the logic we want to implement is that the primary and the secondary CIDR is learned by the CNE, but only the non-overlapping secondary CIDR is advertised on-prem. So how do we do that? There are multiple ways to achieve this. Option one is to apply inbound route filter on the VPC attachment directly. So if we do that, the primary CIDR is not even inserted into the dev segment. Now you may not want that. You want the other dev VPCs or other VPCs to talk to the primary CIDR. So second option is let's apply that in the segment sharing. So here the route is inserted into the dev segment, but does not make it to the hybrid segment. But you may have other hybrid networks like Direct Connect or site-to-site VPN, which may want to access the primary CIDR. So what can we do? So we can also do option three, which is apply outbound route filter on the connect attachment. So the route makes it to the dev and the hybrid segment, but not to that specific attachment. So for our demo, we'll go with option two. So here is our policy, pretty standard. I think you're seeing a policy to filter prefixes and drop it for the third time. So you guys probably are experts now. So we match on the primary CIDR and drop it. And this is how we apply it to our segment sharing. So in my share dev to hybrid, I associate the routing policy. Okay, so let's see this in action. So what I'll do is I'll copy this exact policy, right, because I'm going to apply it. But before we do so, let's look at our dev VPC. So I've already added the secondary CIDR, 172.172.172.0. So that's already done. Great. We can go into our route table for hybrid, US East 1. And we can see I'm currently getting the primary VPC CIDR, 172.16. And I can also verify the same on my SD-WAN appliance, 172.16. So I'm getting the primary CIDR. So the primary CIDR is getting advertised, and I need to filter it out. So I go into my policy, edit my policy, go into JSON, and I will go ahead and, so in my routing policies, I'll add the new routing policy, which is dev to hybrid route filter. Perfect. And then the routing policy reference will be added to my segment share. So let's go ahead and do that. In the segment actions, dev share with hybrid, I'll go ahead and add that. And I create my policy. All right, it's ready to execute. Let's view and apply chain set. Looks good. Apply. Executing. Execution complete. Perfect. So when we go back into our SD-WAN appliance and now do show IPBGP, and perfect. So now you can see our primary CIDR is no longer being advertised. We can also verify that under routes, if we go into our hybrid segment, we should not see that route anymore, 172.16. So you can see there's no 172.16 in that list. But if we go into the dev segment, there should be the 172.16 right there. Right? So you can see it advertised into dev, but it's not advertised into hybrid and to our SD-WAN appliance. Okay, so the route filter is working. Next, let's talk about a scenario where in the European region, you have a VPC, but due to some European regulations, you don't want that VPC to be accessed by the VPCs in US, right? So you don't want that route to be advertised. So the restricted VPC CIDR is learned by the CNE, but as it's advertised cross-region to the other CNE, we will filter that VPC CIDR. So we'll create an outbound route filter to drop the VPC CIDR, and we'll apply that at the segment level cross-region sharing. All right, so this is my policy. Filter EU to US. I match on a prefix, so prefix equals 10.200/16, and I'm going to drop it. Now, the important thing is where I apply it. So Sridhar talked about there's a new segment action. associate routing policy. So I'll use that. I'll define my segment, which is prod. I reference the filter EU to US policy, and I define my edge locations. So I'll apply it as the traffic is being sent, or the routes are being sent from EU West 1 to US East 1, and I'll do the same when it's sent from EU West 1 to US West 2. Right? So the inter-region pairs get defined. Okay, so let's see this in action. So we go into our policy, and now instead of using JSON, I'm going to actually use the visual editor. I've already gone ahead and created the filter EU to US routing policy. As you can see, prefix equals 10.2.16. I'm dropping it. So now I'll go into segment actions. You can see edge location route policy association. That's a new thing which we've added. You can click associate. You can choose the segment, prod, EU West 1 to US East 1, apply the policy filter EU to US. Now I'll just do it for EU to US East, not for US West yet. So let's go ahead and apply chain set. So I'm only blocking traffic from EU to, not traffic, but the route propagation from EU to US East 1. So if you go to our routes, prod, US East 1, search routes, you can see I'm still seeing the 10.2 route. So that's not getting filtered. To dive deeper, I can go into my rib, get routing information, and you can see the 10.2 route is actually coming from US West 2. And I can look at the AS path, and I can see, OK, so 6515 is US West 2, and 6514 is EU West 1. So this 10.2 route is getting filtered from EU, but I am seeing it from US West 2. So what I need to do is go into my edge associate routing policy, and now I need to block EU West 1 to US West 2 as well. And once I do that, now hopefully my US East 1 will not see the EU VPC routes come in, either from EU or from US West. So to verify that, we jump into our routes, prod, US East 1, search routes, and you can see 10.2 route is no longer present, and we can also verify on US West 2, and 10.2 is no longer present. Right, so this should give you an example of how you apply filter to cross-region route sharing for a given segment. All right, so my next scenario is hybrid route isolation. So from my on-premises SD-WAN appliances, I've been advertising two routes, 1064.10 and 1064.20. Now, in my on-prem environment, 1064 is for production environment, and 1064.10 is for production environment, and 1064.20 is for development environment. So what I want to do is, as that routes are being advertised from on-prem and shared from hybrid to production and development, I only want to advertise 1064.10 into production and 1064.20 into development. Now, when you do route sharing between segments, it's all or nothing. Right? So when I do hybrid to prod and hybrid to development route sharing, both 64.10 and 64.20 will get advertised. But I want to restrict that. So the way I'll do it in this example is I'll tag those routes with different communities. I'll do that on-prem, and in my case, I'll do that on the SD-WAN appliance. And then I'll create, so you see the communities are getting added. And I'll create a route policy where I'll match and allow based on that community tag. So I'll have two different route policies, one to match hybrid community, and one to, for dev, and one to match hybrid community for prod. And then I'll apply those communities as I'm sharing the routes between hybrid and production and hybrid and development. So let's see how we can implement step 2.1 and step 2.2. All right, step 2.1, this is how my policy looks like. Match hybrid community dev. Direction is inbound. Again, always, the direction is very important. Here we are going to match on a community. Community in list 65,200, allow. So any routes which are tagged with that community are allowed. And whenever you're doing an allow, you have to do an explicit deny. So here then we're putting an explicit deny saying deny everything else. I do the exact same thing for prod, match hybrid community prod. I match on 65,100 and then allow. And then I put explicit deny in there. Okay, so now step 3, we need to apply those policies in the right place. right distribution point. So here, segment dev, when it is shared with hybrid, I associate the policy. Now, remember, we need to filter the routes as they advertised from hybrid to dev. But here I'm saying dev, share with hybrid. That's why the direction becomes very important. Remember the policy direction? It was inbound, right? But if you have set that to outbound, this would not work. So the direction and how you're doing the segment share is really important. And then I do the same thing for prod to hybrid segment, and I associate the match hybrid community prod. And hopefully this works. Let's see. So this is my SD-WAN appliance. As you can see, I've configured some route maps to tag the CIDRs with communities, and I'm advertising it to my Cloud WAN peers. I can also verify that by going to the RIB into my hybrid US West 2, and you can see the communities listed on the right. These are my Cloud WAN peers, BGP, and on the right is the community. So I can see those communities come in. When I go to prod, I can see both 100 and 200 communities. When I go to dev, same, I can see both 100 and 200, right? But our logic is 100 should be only in prod and 200 should only be in dev. So I'll go ahead, and here we'll create a routing policy using the visual editor, match hybrid community dev. We go ahead and add a rule where we will allow routes which have this community tag, 65,200. And then we also have to add an explicit deny. So 200 drop prefix insider 00/0. Perfect. So this is how you can do that. Now, if you're going to click JSON, what we configured shows up as the JSON syntax as well. So it's a great idea for you to use the visual editor to make changes, and then you can go into the JSON and look at how it's done. So for rest of the stuff, I'll quickly speed up. I'll copy everything from my slides into my routing policy. I'll not wait you sit through all of that copy paste. So that's all done. I execute my policy. It's getting executed. So what you saw in the slides is what is getting implemented exactly. So let's go back into our core network. And now, when we go into our RIB, and for prod US East 1, you can see I only see 65,100 community routes. And for dev, I only see 65,200 community routes, right? So we were able to successfully filter route distribution into our segments based on community tags. All right, so my final scenario here is where I have two different regions with my SD-WAN appliances. Now, both are advertising the same routes, 100, 6420 with that community tag. I spin up a new AWS region, US East 2, which does not have on-prem connectivity. So when a VPC in US East 2 has to talk to an on-premises IP, it needs to go via CNE1 or CNE2, right? So what do you think? Which CNE will it choose? Will CNE3 send traffic to CNE2, or will it send traffic to CNE1, right? Let's see. So we are going to go into my console where everything is configured. I go into dev in US East 2. And here I can also add additional filter. Only show me routes with community 65,200. And you can see US East 2 is receiving that prefix from 3 regions, US East 1, US West 2, and EU West 1. And you can also look at the AS path to see exactly. So 6556 is my on-prem SD-WAN, 655 is my on-prem SD-WAN. Great. Now, if I go to my routing table, you can see the CNE decided to choose US East 1 as the next hop and ignore EU and US West 2. Now, I want to change that, right? So what I want to do is, for dev traffic originating in US East 1, I want to make US West 2 as the preferred hop, right? So my US West 2 has to be primary for dev traffic. So I want to change what Cloud WAN decided for me. And for my prod traffic, I want to continue using US East 1. So the way I do it is, the routes I receive from US West 2, I'll tag them with high local preference, and the route I receive from US East 1, I'll tag them with low local preference. So here's my policy. Set high local preference SD-WAN routes. I match on the community and I set low local preference. So this is high local preference. And then my second policy to match the same routes, and I set low local preference, right? Two different policies, setting the local preferences. Now it's important where I apply what. So for my dev segment, I will apply the low local preference for my edge locations, US East 1 to US East 2. And I'll apply the high local preference for my edge pair, US West 2 to US East 1. So the routes coming from US West 2 will get the high local preference. So you saw how we do this through the CLI, through the JSON. You saw how I do this through the visual editor. Let's do it through AI, right? The Go Kiro. So I'm going to take this as my prompt. I'm going to tell it to look into my AWS Cloud WAN configuration and implement this kind of a logic. So I take my prompt, put it into Kiro, and let Kiro do all the work for me. So now Kiro is going to first call a bunch of CLI commands, look into my Cloud WAN configuration, understand my existing policy. Then I also asked it to look at AWS documentation to understand the route policy feature. So it's now calling an MCP tool, AWS read documentation. It read it. It says, perfect, now I understand the route preference feature. Then it goes ahead and starts creating a policy. So you can see it's creating the policy. And it has now created the policy. It's created a change highlighted document, so I can see what exactly it wants to add. I can verify it. Everything looks good, very similar to what I had in my slides. So I'll accept that, and I'll say, let's go ahead and apply this policy. So when I do that, Kiro will again start, do the apply change set, and go execute this policy. So it takes a couple of steps. If that's done, we can go check our policy version. We can see execution is succeeded. Now when we go into our routes in dev, US East 2, you can see now 106420, the next hop is US West 2. So we changed it from US East 1 to US West 2 using local preferences. And just to verify, prod US East 2 is still using US East 1. So I put all my prod traffic via US East 1 and my dev traffic via US West 2 using cross-region local preferences. Awesome. Now when Cloud WAN has to make this routing decision, it follows a route evaluation logic, right? So most specific routes always wins. But if they're route with same destination, different targets, static routes always win. Then VP's propagated routes, and then it looks at dynamic route. So it looks at local preference first, which was our case, and then other metrics. And if all the BGP attributes is same, then direct connect is preferred, then Cloud WAN, then site-to-site VPN, then transit gateway peering. And if everything is same, then it uses a deterministic random approach. All right, some key considerations before we wrap up. It requires you to use a new policy version, 2025.11. CNE will transitively pass all BGP communities across all attachments. This is great, but it wasn't the case before, so it's good for you to know. The RIB presents routes before routing policies are applied on the local CNE. Routing policy direction is really important, and it's unidirectional. When you're associating prefix lists with a CNE, must be unique. Some applicability considerations, BGP community match and modification are not supported on DX and transit gateway peering attachments. You cannot replace or remove ASN specified in your CNE configuration. Replace ASN is not supported cross-region. Route policies are not supported for network function group service insertion. So if you're using service insertion, continue to use it. And service insertion leverages static routes behind the scenes, so that always takes priority over what you do with BGP. All right, so just to recap, route filtering, route summarization, BGP route property modification, it opens up a huge world of possibilities. I showed you some examples, but we are really excited to see how you use all of these capabilities to modify your networks and do crazy stuff in the world of routing. Now, with that, we would like to thank you for coming. Now, I know you all are going to open the session app and give us 5-star CSAT review. Only because of that, I put a tiny URL here, a QR code. If you scan this, you will get access to my entire policy, which I had shown in my presentation. And that's a real policy which works, so you can use the syntax and modify it for your use cases. With that, we are at time. from Sridhar, Chijun, and I. Thank you so much for coming and joining us, and have a great reInvent.